could be further developed. As I explained, there were 9 companies. The data's been anonymized. I've got 8 mills here with a summary of results. You can see there are the A's and B's and C's, the different mills. There were quite a wide range of yields. Some had outgrowers, some didn't. And there was a big range of previous land use. And then on the right, we've got the final result. And I'll just show those in a slightly different format. You can see there's a range of net emissions. These are reported in tons of CO2 per ton of CPO on the left, no, on the x-axis. And you've got two companies with negative emissions. In other words, they're net sequesters. And these were the 2 companies with very low biomass when they started. They're in the first generation. The highest, then the C1 and C2 is a company with different proportions of peat. And C1 had 25% peat, C2 had 75% peat. But these 2 companies also had quite low biomass at the beginning of the cycle. So although they had peat emissions, they were cancelled out to an extent by the low biomass to start with. Then the other companies were all on mineral soils, F, G, and H, with different yields, different mixes of land use. Typically around about 1 ton of CO2 per ton of CPO. Now, I'm just going to look at the results for 2 companies, and we have the first one, the base case, and it shows the contribution of the different sources of emissions. This is low biomass to start with, but high peat. So you can see that 43% of the emissions from peat in this situation. Above the line are the emissions, below the line is sequestration, and the bar in the yellow is the net. So it gives you an idea that it shows you the land clearing, the peat, and the methane are the dominant sources. This shows you some simple scenario testing. We weren't really sure about the proportions of the grass and the shrubs at the beginning of the cycle, so that we have plus or minus 25%, depending whether it was all grass or forest. And then we could look at playing around with flaring a biogas and generating electricity from that. And then you've got 2 peat scenarios, low and high emissions from peat. Second example, we have a company with the land clearing dominant source of emissions, and then the methane, and then the other sources. The net emissions are 1.15, and a few sensitivities. Capturing and flaring the methane, you've reduced the net emissions from 1.1 down to 0.57. You've halved the emissions by capturing and flaring. And then you can reduce it further by generating electricity. And then this was a composite scenario looking at what, in the long term, with a 100% replant, capturing your methane, and you're down to 0.31 tons, which is quite a low number. Lastly, come to some scenario testing. We populated the model with dummy data, and base case is at the top, with a mix of previous land use, some peat, no POME. And that's case 1, gives you 0.7. Above the line, again, emissions. Below the line, sequestration. The different colors are the different sources of the different components. The peat is 5.09. I should say that this was with a fairly conservative emission, 23 tons of CO2. We subsequently revised that in the default up to 38, and that 5.09 goes up to 8. So you can see 100% peat is giving you very high emissions compared to the mineral soils. And just strip out that the peat, just so that we can show the different components. And you've got 1 is the base case, 2 is all forest. This is logged forest, and you've increased the emissions up to approximately 1.5 tons. The blue is the land clearing, the purple is the methane, and the others are all relatively minor. And then 3 is 100% grassland. If you're clearing 100% grassland, you can see the blue has shrunk to a very low number, and the net emission, your net sequester, the emissions have gone down to -0.6. And then the last two, number 5, when you're taking out all the, when you're generating electricity from from the methane from the POME, and you're down to 1/4. And then finally, we've got another composite, which we think is a sustainable situation for palm oil on mineral soils, capturing, is 100% replant, no peat, capturing, converting methane to electricity around about 1/4 ton. And finally, we've completed the pilot phase. Some recommendations came out. We've been updating the carbon stock values. We've updated the peat emission factors. We've already done that. We've incorporated the biofuel calculations from biograce to be compatible with RED, and with our colleague Amir from Shell. Please talk to him about that, not me. And then following on after this presentation will be the next phase is to do a peer review of POME GHG. We're comfortable with it, but it'd be good to get some independent view of it. And once that is complete, then we will be doing, making it more user-friendly and producing a manual. And I'm 1 second behind. Thank you very much.